In this first video, I'm going to talk about vertical transformations of the graph of a function. Okay, so we're going to look at section 2.5 from Blitzer. Okay, the idea is take a function, do something to it, and see how that affects the graph. Create a new function by essentially modifying the formula, and then how does that change the graph? All right, so we're going to be looking at this fixed function f throughout. F of x is defined by the formula x squared, but the domain is only the interval from -1 to 2. So you're only going to see the graph showing up over the interval from -1 to 2. Now we're defining this function g by the formula g of x is f of x plus 2. All right, so we're adding 2 to each of the outputs for f. How does that affect the domain, the range? What does the graph of this new function g look like? Okay, that's what we want to answer. Okay, so to do that, I'm going to go over to our scratch paper here. I've got the function graphed from -1 to 2. Again, you're not seeing the whole parabola, just a portion of it. All right, and then we want to know what's the domain, what's the range. Okay, to answer that, to plug a number into g, well, you got to plug that number into f first, and so you're only allowed to plug the numbers into g as what you can plug into f. So the domains are the same, right? You have to directly plug into f, so the only ones you're allowed to plug in are going to be from -1 to 2. The domain is the same as it is for f. The range is a little bit more delicate. We can see from the graph that the range is the interval of 0 to 4 on the y-axis. We know y can only be between 0 and 4 for the function f. All right, now another way to write that is to say that f of x is between 0 and 4 using our function notation. Now, looking at our formula for g, we want to know where is f of x plus 2 lying between? What two numbers? We want to know f of x plus 2, is that less than or equal to what and what? All right, now to accomplish that, we can look at our previous inequality. All we want to do is add a 2 in the middle. We can add a 2 in the middle if and only if we add it to the left and right hand sides of our inequalities. So we get that 2 is less than or equal to f of x plus 2 is less than or equal to 6. What's in the middle is the function g. All right, so another way to write it, just put in 2 is less than or equal to g of x, which is the outputs for g, and that tells us what our new range is. The range is the interval from 2 to 6. Okay, now looking at this a little further, how does that affect the graph? What did we do, right, to obtain the new range from the given function f, right, the new range for g from the given f? We took the output values, okay, for f, and we added 2 units on it. So if we wanted to graph the equation y equals f of x plus 2, we're just taking the y values for the function f, adding 2 on. All right, so we're going to see that that shifts the graph of f up 2 units. Okay, so let's take a look at that. All right, so here's what we're thinking about plotting. We're taking a function and we're adding a certain number onto it. Start at the bottom again. Okay. Starting at this over, here's our original graph. All right, so the scale looks a little different from the scratch work, but it's between -1 and 2. Got our parabola starting at here at height 1, going down to 0, then going back up to 4. Our range is from 0 to 4. Now, if we add 2 on to the outputs, it shifts the graph, each point on the graph, up 2 units. And now our new range is from 2 up to 6. Lowest point is y equals 2. Highest point is y equals 6. Okay, similarly, if we wanted to take the function and subtract off a certain positive number, say we wanted to subtract off 4, okay, what's that going to do? It's going to shift the graph down 4 units. Okay. All right, so that takes care of the first example. All right, so we'd see if we add or subtract a number, that's just going to shift the graph up or down. Not going to affect the domain, but it will affect the range. Okay, for the next one, we're looking at the same function f, and now we're defining 2 new functions in this next example. One is called g, one is called h, defined by these formulas 3 times f of x and 1/2 times f of x. What's that going to do to the graph of f? What are the domains and ranges of these new functions g and h? Okay, back to our scratch paper. Let's write that out. Okay, so again, writing g, the definition of g of x for this example is 3 times f of x. To plug a number into g, you plug it into f, and therefore you're only allowed to plug numbers into g that you can plug into f. Okay, you have to be able to plug the same values in. Okay, you can't plug any number into G that you cannot plug into F. So the domain for G is the same. Again, it's -1 to 2. For the range, again, we're going to state out that we know for F, the range is between 0 and 4. Writing this with our function notation, we can say that f of x has to range between 0 and 4. We want to have a 3 in the middle. We want 3 times f of x. That's the formula defining G. To do that, we can multiply each side of the inequality here, left, right, and middle, by 3. 0 times 3 is 0. We get 3 times f of x in the middle. 3 times 4 is 12. Now in the middle, we've got our new function. That's g of x. So g of x is between 0 and 12. So that's our range for g, the interval 0 to 12 on the y-axis. Now how does that affect the graph? Okay, what we're going to see is that's going to stretch the graph vertically by a factor of 3. Okay, so let's take a look at that now. Okay, this is the end result. We want to start out with our original graph. Okay, this is the graph of f, and we're going to multiply that. We've got c times f of x here. All right, we're going to multiply that by eventually 3. Let's see what happens. The graph is getting pulled upwards. It's still graphed over the interval from -1 to 2. Let's play it again. But it's getting stretched, vertically stretched by a factor of 3. This point here was down here at 1. Multiplying it by 3, we get to the height 3 on the y-axis. The point here at the origin was at height 0. Multiplying 3 by 0, it stays there. All right, so any point on the x-axis is going to get fixed at 0. The value of the function, it will be 0. Over at 2, we started out at height 4, excuse me, and we multiplied that by 3 to get up to height 12. All right, so our new range is from 0 to 12 for the function g. Okay, coming back to our scratch paper, let's look at that second function in that example, which was h of x defined by the formula 1/2 times f of x. Okay, now again, we want to answer the two questions. What's the domain? What's the range? And then we'll look at the graph. The domain, again, is going to be the same. All right, you're only allowed to plug numbers into h if you can plug them into f, and therefore it has the same domain, -1 to 2. For the range, we're going to start out by looking at the range for f. All right, the range for f we know is between 0 and 4. All right, and now, again, writing that back out with our function notation, y is the same as f of x for the graph of f. So f of x has to be between 0 and 4. Now we want to put a 1/2 times f of x in the middle. We can do that by if we multiply on the left and the right by a half also. Half times 0 is 0. 1/2 times 4 is 2. All right, so and in the middle we have h of x. That's what our formula is defined to be. And so we get h of x is between 0 and 2 this time. All right, so that's telling us the range for g is the interval 0 to 2. If we multiply each of the output values for f by a half, we're going to make them smaller. So this time our graph is going to be compressed by a factor of 2. Okay, so let's see how that looks. So again, starting out with our original graph of our function. That's not our original graph. That's after we've transformed it, excuse me. Starting out with our original graph, we got the graph of f, which is y equals x squared, over the interval from -1 to 2. All right, that's our picture. Now, when we multiply that by eventually 1/2, what we're going to see is the graph gets smushed downwards. It gets compressed towards the x-axis. We're decreasing the y values. All right, so it's got to be smushed down or compressed downwards. Okay, so that's what's happening for the vertical transformations. Notice we're doing an outside change in each of these functions. We're adding a number or subtracting a number on the outside. We're multiplying by a number on the outside. That affects the graph only in a vertical way. It only affects the range, not the domain. Okay, so adding or subtracting moves the graph up or down. Multiplying by a number either stretches it if the number is bigger than 1 or compresses it if the number is less than 1.